Hello, everyone. Thank you for being here. Thank you, everyone, for organizing this amazing event. The venue is awesome. I've been here before, and every time I come, I really enjoy it. I hope you're having a great time. I know I am. So my name is Bernardi. I am a data scientist in Booking.com, and today I would like to talk about the 7 powers of machine learning, which is a little framework, a little tool that we created in Booking.com to make sure we use machine learning in a commercial, sensible way. Let me start right away because I have actually a lot of content, and let me give you a bit of a motivation for machine learning in Booking.com. So here I hope you can recognize this page. It's a search results page of Booking.com, and I wanted to kind of illustrate how much machine learning we use. So I said maybe I can remove all the components in the website that are somehow built on top of a machine learning system, and this is what you're left with. Nope. Yeah. Pretty much nothing. Almost everything you see in the website is actually somehow built on top of an application of machine learning algorithm. I recognize it's not very useful because there's not a lot there. So I said I can do maybe the opposite and actually highlight those components where machine learning is being applied. But it's also not really useful either because you can't really see anything everywhere. Machine learning is everywhere. And this talk is a little bit about how we got here. How do we manage to come up with so many ideas to apply machine learning and to actually make it in a very commercial, reasonable, and valuable way. Now, before I jump into the 7 powers, before I jump into the framework itself, I would like to go back a little bit to the basics and give you a bit of a vision about what is machine learning. This framework is very much used with product managers and user experience experts, so they are not really much into technical details about this technology, so we always try to start from the basics. And this is the definition that we give to them. I know in the room there are a lot of people that know very well what machine learning is. Please bear with me. I think this is a definition that is quite useful. So let's take a look. So imagine you have a problem that is about classifying, say, 100,000 pictures into mobs or dogs. So that's your task. Very useful system. Now, humans are pretty good at telling whether there is a dog or a mob. But for the ones in the back, I did it for you. Don't worry. These are the dogs. The others are the mobs. So how do you do this, right? Because you don't really want to classify 100,000 images yourself, one by one, although I'm sure humans are very good at this. Why? First of all, it will take a lot of time. Second, you could probably do something much better than spend your time like this. So better try to automate this, right? And how do you do that? Well, use a computer. So how do you use a computer to automate this? Well, you write a program. And if you wrote a program, you know that the program will simply take the picture as an input, and it will output whether the picture is about the dog or a mob. Now, if you try to write this program, how would you do it? You have to maybe load the picture in memory, look at the pixels, see if there is a red pixel surrounded by some black and white. Maybe that's the tongue of the dog. If you don't find this, maybe it's not a dog and it's a mob. So after 15 minutes doing this, you will realize that this is impossible. You can't really write any reasonable set of rules based on the colors of the pixels to tell whether the picture actually contains a dog or a mob. And that's where machine learning comes in. And the idea of machine learning is, look, this is a program that I really care about because it's very important that I can tell whether there are dogs or mobs in these pictures. And it's very difficult for me to write this program. So machine learning says, well, don't worry, you can collect some input-output pairs of this program. So you can say, take some pictures that you know are dogs or mobs, and you can do this with, say, 100 yourself, or you can go just to Google and Google dogs, and you get a bunch of dogs, you Google mob, and you get a bunch of mobs, and that's it, right? And then you write the program yourself, but this one is much simpler. This one is a program that we can actually write. That uses the technology that was developed ages ago from machine learning and statistical learning. And the interesting thing is that the output of this program is that program that we actually care about. And this is it. This is how machine learning works. It's all about writing computer programs with data, with examples of the input and output of the program that we actually care about. Now, this might sound a bit naive and a bit obvious also, but it's quite important, and every time I use this, especially with the product managers and UX experts, it really has an effect on them. Of course, we have funny names for all this. For example, the program that we actually care about, we call it an algorithm, a model, or something like that. The input to that program, we call it input features or covariates, even more complicated. And my favorite one is the output of that program that we care about. We call it the prediction, although most of the times we don't really make any prediction. The dog is there or not. There's nothing to predict, right? It's simply an output of a program. And it gets worse, right? The data that we use, which are just examples of the input and the output of the program we actually care about, we call it training data. And the algorithm that we write, which is actually, it's not easy, but it's much easier than the algorithm that we actually care about, or the program that actually makes the classification, that one we call it the learning algorithm. It's just a program. But we like to create this metaphor of machines learning. But this is just a metaphor. And don't get me wrong, there's nothing wrong with this sort of jargon. I use it all the time myself. But I think it's very useful to remember that when we use machine learning, all we're doing is programming computers. And the computers are the same for a long, long while. They just get more powerful, but all machine learning is doing is helping us to program computers. So that's my pragmatic definition of machine learning. It's just a way, just a method to write computer programs. And a method that is based on examples of inputs and outputs of programs that we care about. And yeah, we've seen this in the past. When SQL was invented, when relational algebra was invented in the 50s, that was a whole new way of programming computers. When object-oriented design was invented in the 80s, also, there was a whole new way of programming computers. And today, we're probably going the same way with cloud computing or even maybe functional programming. But machine learning is also one of them. But I don't mean to sort of dim down or water down the meaning of machine learning. It is a bit special when you compare to these other sort of techniques of programming computers. And what's so special about machine learning? Well, it showed us that computers are capable of things that we didn't know it was possible before. Like the things that happened in the, say, 10 years ago about vision, the things that are happening today about language, probably 30 years ago, nobody thought that computers could actually do that. And machine learning, still being just a way of programming computers, showed us that we can do these amazing things. And I think that's kind of the twist of this pragmatic definition. And in Booking, we came up with this idea of the 7 powers of machine learning to kind of capture those amazing things that you can do with machine learning. So let's take a look at them. There are 7, so it's quite a lot, actually. The idea is that I can quickly run you through these 7 powers, and then we're going to see 2 or 3 examples, specific examples, Booking.com, of course, depending on how we're doing with time. So, example number 1, predict the future. This is the one that everybody associates with machine learning. The idea is simply that there are some events that you care about that may or may not happen in the future, and machine learning can help you to predict where those events will happen. These are obvious. There are many obvious examples, like churn prediction, cancellation in the case of Booking. We want to predict where the user will cancel a reservation that was made, conversion, as we just saw. These are all true predictions, right? And it's a power that is, of course, really effective, really powerful, but it's also a bit tricky, because usually if we're interested in predicting something about the future, we're also interested in influencing that. So if the user will churn, we don't want that. We want to do something to prevent that from happening. If the user will cancel the reservation, we don't want that. We want to make something to prevent the cancellation. And that kind of creates a feedback loop, which is not that easy to handle, and it can be tricky, and it's definitely getting in the way of actually driving value with predictive models. So power number 1 is very powerful, but it's not the one I would recommend anybody to begin with in the context of a business application. The second one is probably the easiest one. It's when you want to guess something that is actually there. It's a bit of fill in the blanks problem. So it's not something you want to influence, but something you need to know. For example, in Booking.com, usually we want to know whether the user is traveling for business or leisure. This is not a prediction. The user is traveling for business or leisure. We just don't know, because not everybody tells us what type of trip they're trying to do. So we want to guess this, and this is a very straightforward. It's a very simple, and it's probably one of the more straightforward applications of machine learning this day. And it's also very powerful, because if you have this information, that you can use it for improving the user experience and stuff like that. We'll see a concrete example of this one in a second. And power number 3, I have it here, it's much easier. So power number 3 is describing alternative feature. This is a very interesting one. This is about the forking path of the future. So essentially, you have several options, you can do several things, and you want to know what would happen if I take option A, or what would happen if I take option B. So in a sense, it's a prediction, but it's also a prediction that you can control because you want to choose what to do next. For example, this is very useful to decide whether you want to discount a user or not. You want to do it depending on whether giving the discount will increase the chances of the user churning or not, and examples like that. This is a very complicated one, but it's super powerful also because it allows us to directly drive decisions in some sort of automated way. So these are the three ones on top are a bit related to the time. So guess something about the present, predict something about the future, or this trying to compute what will happen if I do different things. But there are other things which are super interesting. For example, power number 4, the green one, is untangled complexity. This is one that I like a lot, and we'll see a very interesting example. But this is essentially about business rules that are too complicated. For example, chess. Chess is a very complicated game because the rules are very weird. It takes time for humans to learn them, but the computer can learn the rules immediately. Recently, DeepMind released, what is it called? Mu, Zero, Mu, Alpha Mu, I don't know, something like that, that actually learn to play chess without knowing the rules beforehand. Alpha Zero actually knew the rules, this one doesn't even know the rules. So machine learning is very good at simplifying rules that are very complicated. So if you have a system where you have a lot of business rules, which are very difficult to compute, well, probably machine learning is a very interesting application. And we're going to see a very nice one from Booking. This is number 5, is my favorite. This is my favorite power. It's about subjectivity. In many situations, we need to know whether a picture is pretty, or whether a price is a good price, or, I don't know, whether a sound is pleasant. So these are very subjective ideas, which are not very easy to grasp by humans. If you put humans to this, all kind of biases will creep in. What you think is pretty, someone thinks is awful. What you think is a good price, someone thinks is too expensive or even too cheap. So, and this is very difficult to do. It's pretty much impossible to do with humans, so it's very difficult to get it right. While machine learning is actually pretty good at doing this in a very actionable way. You can really create models of how good the price for a hotel is, for example, in Booking.com, or how pretty is this picture, how representative it is of the hotel, and so on. And machine learning is helping us a lot to do that. So these 4 and 5, I call them the tricky powers because they're not very obvious, right? They're very, you need to think a little bit about them. And then we have 6 and 7, which are kind of the most simple ones. Automating human tasks, it was said before. Automation is, of course, the perfect space for machine learning. Everything that is repetitive, that is something we need to automate, like review moderation, or any type of fraud detection, for example, that requires a lot of repetitive tasks, we can automate with machine learning. And finally, one that is super powerful, and it's also very, very simple, is optimization of products. For example, if you want to optimize the number of rooms for a group of people in a hotel so the price is minimum, this may be a difficult problem using quadratic programming, but if you try to do it with machine learning, it's much simpler, it's much, much powerful. So whenever you have a thing that you want to optimize for, machine learning can definitely help you. Okay, that was a bit too fast, maybe not. So 7 powers of machine learning. Of course, I don't expect to get them like that. You can, take the picture. I'm sure I'm going to share the slides so you can take a look. How do we use them at Booking.com? We just make cards, so we cut them, and then we deal them, and then we brainstorm about it, and people ask questions about whether this fits in this power or not, and then they start getting some sort of understanding of these powers. But the actual point is that when we go into one session, after 1 hour, we have maybe 50 ideas for applying machine learning. Maybe, say, 20 get actually implemented, and maybe 1 works. But that's a lot, because that's 1 hour of brainstorming, and 1 was successful. And we do this every month, every Q, I don't know exactly, but you get the point, right? And you can decide how to use it actually. So I think I can jump into examples, which actually makes it much more interesting. So this is what we call the missing children case. So it all started with an insight from our database that was showing that when you travel with kids, if someone is traveling with kids, and then we know that they're traveling with kids because when they come back from the trip, we send them a survey, and if they want, they can tell us. So they tell us, I travel with young kids. But then we go back and look at the shopping experience of these people that just told us they're traveling with kids, and we see that they never filled, 30% of them never filled in this information. And this is super, of course, got our eyes frown, because what does it mean? Why these people are traveling with kids and they don't tell us while actually shopping, right? Of course, we checked all kind of obvious hypotheses, like, okay, there is a bug in the website, or maybe people is trying to kind of not telling us so they get cheaper prices. So we check a lot of things, but nothing was really properly explaining this behavior. So we came up with the last hypothesis, which is simply that they forget their kids. So the idea is very simple. You go into Greece with your kids, and you go to booking.com, and you say, okay, let's go to, say, I don't know, Mykonos Island, and you go search, hit the search button, see all blue, because in Greece everything is blue and white. And then you saw this amazing resort, you click there, it's free cancellation, it fits your budget, you book it, and to find out that you forgot Kevin. So at that moment, what you need to do is to cancel your reservation, and then you start over, and it's already a hassle. And in the worst case scenario, people actually get to the hotel with the 10-year-old kids, and they say, no, but you didn't tell us that you have a kid, so you won't fit in the room. You need a new room, and you have availability, and you can imagine how much of a nightmare this might be. Yeah, and then if you can recognize this this lady, and that tells a lot about your age and also about mine, but so yeah, so that's our hypothesis, and it's very important to highlight that this is just a hypothesis. We're not assuming that they forget their children. We're just having this hypothesis. How can we check this? How can we develop some sort of experimentation? And probably you know how much we rely on experimentation in Booking.com. This is kind of one interesting example of how we actually do it. So how can we design an experiment that tells us, that helps us to collect data that supports or rejects the hypothesis that some travelers are forgetting their children? Because the simple answer is simply just go and ask, right? Ask everybody every time you go into the website, are you traveling with children? Are you traveling with children? This, of course, doesn't make sense. Everybody would bounce and book in Expedia or Airbnb or I don't know. So we don't want that. So what we did, simply machine learning to the rescue, and we looked at the 7 powers of machine learning, and we found that, of course, we can guess the fact about the present. So the guest is traveling with kids or not. That's already decided. Of course, we could influence that, but that's not our goal. Our goal is to know whether the guest is actually traveling with children or not. If they are traveling with children and they didn't fill the data in, we can tell them, hey, why don't you give us your data about the kids so we can show you better recommendations. Of course, they're in control. If they want, they can just dismiss this message and drop it and continue doing whatever they want to do. Or maybe they realize, oh, Kevin, and they enter the data about Kevin, the age, whatnot, and I guess in that case they have a lot of kids, so probably they wouldn't do it. I don't know how would that work, actually. So yeah, so we did that. We built a model that tries to take input from the user, like what are they going, how much in advance are they booking, for how long do they stay in the hotel, stuff like that. And to give an example, imagine you have one adult on his own going to Gunzburg, which is where Legoland is, for 15 days. 60 days in advance, and before that they checked Disneyland in Paris and Asterix Park. So probably this person is forgetting about his or her kids, or we should call police, I don't know. So, but something is fishy. So this is what the model is trying to do, to say, okay, something doesn't add up here, so maybe we should ask this person, hey, it looks like you are forgetting your kids. Maybe the model is wrong, but you can see the cost is not really high. So we built this model, we shipped it in all platforms, so you can see mobile, web, tablets, I think, and desktop, of course, and it was very successful. A lot of people was actually forgetting their kids, and it drove a much better user experience, and of course it brought a lot of value for Booking, because more people found a good reservation, a good hotel to stay, and increase the conversion rates. Good, so that's one case where you can apply power number 2, which is to guess this fact about the present, to fill the blanks. Let's look at another example about booking homes. So you know, probably, maybe you don't know, but in Booking you don't only are able to book hotels, you can also book homes. And in this case, the idea was to kind of increase the awareness of homes and maybe the profile, to say, look, maybe there are not good hotels in London anymore because it's only 2 days in advance or 3 days in advance, but maybe you can book a home, right? So we wanted to highlight what's good about homes that you don't really get that much in hotels. So we conducted the whole user research, or we go in person and tried to collect feedback from our customers for real, and they came up with a lot of reasons why they would prefer to stay in a home versus a hotel. And we said, okay, maybe we can use those facts that they told us to highlight in the pictures. And one of the things they mentioned is, for example, the kitchen, or the living room, or the barbecue, or the patio, or the terrace. These things are very hard to get in a hotel, but are not that hard to get in a home. So we say, oh, I know what we can do. I was the machine learning guy there. I said, would you just do a vision algorithm to check whether in the picture there is a kitchen, or there is a living room, or a barbecue. Of course, we cannot do this by hand because we have like 60 million pictures, so it would take forever. So we decided to use, of course, power number 6, which automate a human task. We're just automating the tagging. So the algorithm, you can check everything out in there is a YouTube video by the author of this algorithm, Emrah Tasli and Stas Girkin, where you can check all the technical details about it. It's in PyData, I think, 2016. So what the algorithm does, it will try to pick up some features. For example, here you can see it's seeing the coffee machine, the counter. I think there is a tap, of course. There is a bottle of wine. And so this all gives away the fact that this is a kitchen. And the same for the living room. It will pick up the TV and the lamp and the curtains in the back, and we'll see that this is a living room. So we were very happy with this algorithm. It was very successful in the sense that it was very good at predicting or telling whether this is a kitchen or a living room. And then we go run the experiment, we put it in production. What happened? Nothing. No effect whatsoever. And then we go and say, okay, what's going on, right? Well, you can imagine, right? If you're a person and you can see, what do you see there? You see a kitchen. What does the algorithm see? A kitchen. And then we say kitchen. It's not very useful, is it? It's not really compelling at all. So we realized that what we were doing was completely nonsense. And we decided to call to our amazing team of copywriters. This is a team of people in Booking.com that take care of managing all the communication to our customers. And they said, okay, well, maybe we can use something more catchy. And that's quite powerful, because where you see a kitchen, and where the machine learning algorithm sees a kitchen, a copywriter actually sees the freedom to eat whenever you want. And where you see a living room, and I see a living room, and AI sees a living room, a copywriter actually sees space for everyone to be together. And this simple change actually changed the whole game and really increased our KPI by I think 1% or something, which is a lot. The morale here is twofold. The automating things is very powerful, but you always need to, it's very good sometimes to combine this with human intelligence. And in this case, it's super, super haptic how that works. Okay. I have 7 more minutes, so I want to run through the last example, which is my favorite one. So this is a very interesting problem also for booking for homes, because in homes we don't have we have stars, right? Like hotels, like 1, 2, 3, 4, 5 stars, right? I'm not talking about the user rating, I'm talking about the official star rating. And that's a big problem, because you can see there that the unrated amount of properties is in the thousands, right? It's covered by the box, but it's more than 1,000. And this is problematic because people is really used to use this approach. I want a 4-star, I want a 3 stars, and it helps them to judge the price, and it helps them to filter. So if you don't have this attribute in your property, it really hurts the user experience. So we say, okay, can we come up with a system to assign a star rating to our homes? Yes, sure, because there are institutions that already do this, right? And they have specific rules to actually assign the proper star rating to each hotel. So we got in touch with the European institution that takes care in Europe, and we asked them, hey, how do you do it? And they send us this PDF with a bunch of rules. You don't need to read them, but you can see there are already some exceptions on the bottom. But this is just the first page. This is the second page. This is the third page, and this is the fourth page, and this is like actually 52 pages. And when we got to requirement number 50, it says that you have to have up-to-date magazines to be a 5 stars. Otherwise, you cannot be a 5 stars. Okay, we're not going to do this. So this is a case where the businesses are super complicated, are super difficult to apply. Now, this is only for some countries in the European Union. For countries in different continents, it's different. It's a real mess. It's really difficult to do this on our own. So what do? We apply one of the powers of machine learning, which is simplifying complexity or untangling complexity. It's a very much complex problem that we use machine learning to make it much more actionable. And how does it work? So we use some features like amenities, services, location, review score when we have it. Usually we don't have it for new homes, for example, and many other I cannot tell you about. So these are the inputs, of course, of our machine learning model. And then the output is a bit tricky. So how do we get the label? Because in the end, we need to have some labels about what is the correct rating to assign. So what we did something very interesting, which is we look at people that book a lot with Booking.com. And hopefully those people book, say, for example, 10 hotels. And imagine out of those 10 hotels, most of them are between 4 and 5 stars. And suddenly they book a home. So what do you think that home should get, right? If it is a guy that always books 4 or 5 stars hotels, when they book a home, probably that home is also 4 and 5 stars. So it's a bit more complicated than that, but that's the idea, simply to look at the behavior of heavy hitters and try to transfer that to homes, and that gives us kind of the ground truth data. Then we build a model. So in this case, you can see many hotels. Some of them are class 5, others are class 4. So the average is 442. So if this guy books a home, and then when he comes back, he says he's happy with it, then probably that home is also 442, 5. So we do that with all the data we have, and this is where being a huge company, Booking.com, really pays, because we have a lot of users that actually behave like this, so we can actually build a good model. Yeah, so that's how it works. That's how we apply this untangling complexity. You can see it's much more simple, right? It's just the input, output, build the model, validate, of course. We're very careful with this. For example, in Croatia, they do have a star rating for homes, so we can hold that out and see if the model actually predicts or estimates the star rating in a aligned way with what happens in Croatia by the official institutions. If you want to know more about this, the actual author of this is around, Anastasia. You can talk to her. She will tell you all about the model, or maybe not all, but many things about it. Yeah. Cool. So I made some pictures to make this a bit more interesting. So here we have Villa Emanuel. This is in Greece. You can tell because everything is white and blue. And this is indeed a 5-star. If you look at it, there's nothing wrong with this guy. It's an amazing property. I totally recommend it. I haven't stayed there, but I can recommend it anyway. Then you have the Bottiscop Bush Villas, which I think is in Cape Town. And this one is 4 stars. When you look at it, it's hard to say what's wrong with this one. But when you look at the map, it's really far away from everything. So location is not great. And that's why I think the model says, OK, maybe 4 is better than 5. And finally, you have the CMG Gambetta in Paris. And this one got assigned 3. I shouldn't say 3 stars. These are not stars. These are dots. Stars is only for hotels officially. This is home, so and you can see the icon is different because we want to be transparent to our customers about, hey, this is not stars assigned by any official institution. This is an estimate that we compute using algorithmic approaches. And this one, I think the problem with this one for 3 stars was the picture is very nice actually, but it's very small. It's very small. It doesn't look small, but it's very small, and it's also, I think, in Nanterre, in some sort of in the outskirts of Paris. So that's why I think it got 3 stars. Yeah, so that's all I got. I think a bit of a summary. Remember, machine learning is just a way of programming computers. We're still working with von Neumann computer. Didn't change for 50 years or more, I think. But it showed us that we can do amazing things. Machine learning is really showing us that computers are much more powerful than we thought. And the 7 powers of machine learning are just a method, a small tool to actually help you to exploit those powers as much as you can. And that's all I got.